what does SDI in mathematics look like for us? Now, our agenda for today is common characteristics of our special needs students. What does a special needs student look like? And then identify what are their motivators and their behaviors. And of course, instructional strategies for mathematics. What are those? And I'm really going to focus a lot because if you've sat in on Chastity's today, you know that what SDI is, but I want to focus on the instructional strategies for mathematics that we're going to actually be using because SDI is truly instruction. And then, of course, ways to demonstrate that learning, and then documentation of of our SDI and the progress monitoring that we're doing. So, what is SDI? Well, it is instruction designed by, and it needs to be the special ed teacher, or it can be an OT, PT, or speech language that is tailored to a particular student. It addresses their IEP work, and it also addresses the disability in which they have. It is providing the modifications and the adaptations to the content that allows them access to the general curriculum. Now, SDI is a support to accommodations. It is the instruction. Again, we're back to instruction. It is the instruction on how to use a calculator. It is also the instruction that you provide to the student for graphic organizers or how to do content scaffolding. So that's big for our students. So what is SDI? Like I said, it's provided by the special ed teacher, the OT or the PT, and also it is provided by the speech language. So working with those people. One of the questions that may be asked is, can a paraprofessional do SDI? Well, here's the deal with that. A paraprofessional may provide the same type of things that you have them do, but they are not providing, they can't provide the instruction for SDI. So keep that in mind. Questions to ask yourself when we're determining SDI is, do making these specially designed instruction decisions, are they based on the student's needs? When we make these, are we basing them on the student's needs? The next thing, what will reduce the effects of the disability so that the student can access the instructions you're giving them or the curriculum and help the student demonstrate learning? And then, of course, third is, how can I document instructionally specially designed instruction? How am I going to document this? Is it going to be in my lesson plans? Where am I going to document that I'm actually doing this? And then, can the SDI be used on both instruction and assessments? Also, where, when, and who, and how will you provide the SDI? Think about those questions. And then, how will you evaluate the effectiveness of the SDI? And then who will give input and how will you use it to make those decisions? And then how often will you provide that to the student? Those are good questions to keep in mind the entire time that you're determining the SDI that you're going to use for your students. How do we design SDI? Well, SDI is designed for teaching using the student's strengths. What are the strengths that the student already possesses? But look and see, what are some strengths? Do they like music? Do they have a very imaginative imagination? And is there certain likes that they have that you can pull on? And then what's their learning style? Is their learning style through movement? Is their learning style through writing? Is their learning style maybe that they have to have not just movement and writing, but they have to have movement and visuals. So keep that in mind. And then, of course, scaffolding for the students' weaknesses. How are you going to scaffold that material for your students' weaknesses, the things that they need the most? And then differentiate. Are you going to differentiate in the standard, the process, the instruction, or the assessment? Those are the areas that you have to look at. Implementing SDI is a vicious cycle. And it's just like anything that we do in special ed, it continues to flow back. And every year we look at the same things. So, of course, we're going to look at the student's present level, their strengths, their weaknesses, and what they need to access that curriculum. we're going, in this case, we're talking about visual discrimination in this one. So interpreting what is seen. Maybe that student has issues with that. Well, that's going to fall right into word problems. It's going to fall into understanding the math in any kind of process they're doing, reading charts, reading graphs. So can the student identify certain things? And so we're going to look at all of that and we're going to say, okay, how am I going to, what's a goal that they need for mathematics? What do I need for that child to be able to access the curriculum for that goal? And I'm going to make my considerations. At this point, we're talking about color coding. And that's going to be something that I'm going to do. The instruction for color coding is the SDI. And then, of course, our goals and objectives are going to be how are we going to monitor those? And then how are we going to make sure that we're communicating that? So through a progress report. So consider any of these materials that is needed, okay? So where do you want to go? How are we going to get there? How are we going to measure that? And then how did the student do, of course? That's a big thing, our progress monitoring. And then how can we improve? What are we going to change? Those kind of questions is what you need to ask. Now, I don't know how many of you have seen the forgetting curve. If you've seen the forgetting curve, you know that this is for a typical student. And a typical student forgets this really should be within 7 days from the first initial time of learning. Within 7 days have really forgotten 80% of their learning. That's a scary thought. So think about for your special ed student, within 2 to 3 days, that student's forgot 80% of their learning. So we need to consider, how do we make sure that they're continuously learning? Well, repetition's one. We know that. We're going to do it over and over again. And for our students who have severe disabilities, we're going to do it more than that. A typical student needs 3 times in modeling, 3 times in creating a mental image or creating a visual, and then 2 to 3 times of an abstract. If that's a typical student, then our special needs students will need 10 or more again. So 10 or more in modeling, building, creating, then 10 or more times in creating a visual image or drawing, and then at least 10 or more times with the abstract. So we know our students need more time. So how am I going to make sure with an SDI, that instruction, that I'm giving them enough instruction so that they can truly use the graphic organizer, the calculator, those kind of things? What are the characteristics of our special needs students? Just look down this list. Have you seen these very things with your students? And what's one you see often? I'm seeing problems with memory. I'm seeing careless mistakes. Unable to focus on a task. That's a big one. How do we keep them focused on a task? Low math reasoning. That's a huge one. I tell you, another one that was big for me was unorganization. I see that now. And then also another huge one that I see with our students, because if they can't organize, guess what they can't do? They can't also organize inside the problem. They can't put their information together. So they're having trouble just organizing that information. So we want to think about our students as a whole in mathematics. What are the things that they need? First of all, we have to teach them to organize their materials. We want that for our students. And again, that's an SDI, organization, but teaching that organization. And then, of course, our students tend to be impulsive. They want to look for numbers and that's it, right? We're just going to look for those numbers and we're going to stop right there and we're just going to add them all up. Doesn't matter what's being asked of them. That's what we're doing. Many times they'll look at a problem that's given to them and guess what? They don't even pay attention to the sign. Whatever they've been taught that week, whether it's addition, subtraction, multiplication, whatever it is that you taught them that week, that's what they're doing to that problem. They're not even looking at the symbol in the problem. So again, teaching them to step back, look at color code if needed, those kind of things. So that's what we want our students to do. Being able to focus on the task at hand, many times that deals with what's going on around them. And then again, do they understand what's being asked? Lack of persistence. This goes back to one of our wonderful math practices and being able to persevere through a math problem. Our students have trouble with that. One, because they become frustrated. Many times they feel like they're not going to be able to complete it. There's an anxiety that happens for many of our students in the regular ed classroom that comes from time tests. Many of our students will shut down because they see a bunch of problems on a sheet and they just completely shut down. So what is an SDI that I can teach them? I can teach them to organize their thinking by also folding the paper and let's just work through one section at a time. So that's something that they may do. I know I'm going to be overwhelmed or I'm going to be looking all over the page. So what can I do? Because I'm still provided with that same worksheet. What can I do? I can fold the page over to where I'm only looking at one problem. I can use a cover sheet and only look at one problem at a time. And then I feel like I can get through that. That's some of the things that we can do. And again, it's you teaching that strategy. They don't pay close enough attention to details or they make careless mistakes. This again can be taken care of through color coding, and I'm going to show you some of those. Low math reasoning skills. That's going to come to you actually scaffolding the instruction, but it's also going to come about by you teaching them to scaffold. So we're going to talk about that as we go on. Of course, weak visual memory for symbols, word walls, cue cards, those kind of things can be used for that. Now, issues with left and right. Believe it or not, this is huge. And we do some games with left to right if you've ever done equipping minds and getting the students familiar with what is left, what is right, and it's simply by using arrows. So if you're interested in that and you have a student who has trouble left and right, contact Doug Smith or you can contact me and we will set you up with some of those so that you can actually use those in your classroom. Another thing is identifying important information in a word problem. We're going to go through some today and I'm going to walk you through what is content scaffolding progression of a word problem. And then of course, difficulty with spelling. One of the things that will stop a student really quick is feeling like they can't spell certain words. In mathematics, that's an easy one, but we can provide them with a word bank so that they can do that. Is there any of these that I just talked about that we went through that you're extremely interested in? Because I can send you some of that information. Your Kentucky guides. I know Chastity talked about these earlier, but the guidance document for IEPs, that's a huge one. Okay. Look back at that because it's got a lot of good information in it. The other one is the IEP or lesson plan development handout. We call that one our schoolhouse document. Again, that's a very good one to make sure you reference back to. Now, from the IEP and lesson plan handbook, which you guys, I know, have probably all seen this, but if you haven't, there's a part in there for math calculation and math reasoning. The SDI, what the teacher does for instructional practices is these things that they can do. Multisensory teaching strategies. There's a lot of things that we can do with multisensory, but it's that movement, it's that touch and feel that they need. And of course, it's the visual. but we're mixing all of those things together. So that's part of that multi-teaching, multi-sensory strategies that we want to do. You get a lot of this with movement that they do when they organize. And then, of course, time delay is one. My one that I go back to all the time is modeling. I'm going to say right now, modeling is huge. And the reason why CSA is one of the things that I push for every student, and the first thing they do is they use manipulatives and they model. And it's huge on the Hattie effect size. Of course, direct instruction in reasoning strategies, word problem strategies, that's another one. If you have a student who has needs for vision or hearing, please feel free to reach out and talk to whoever your people are in your building that deal with visually impaired students or hearing impaired students, or in your district. You may only have one in your district, and that's fine too, but reach out to them. Also, if you need somebody, we have Heather Hall here, and she is from the Kentucky School for the Deaf. We have Miss Tony Harden, and she is from the Kentucky School for the Blind. So feel free to contact those two. And I'm just going to go through a few of these that I feel really, really strongly about. I'm not saying that this is right for your students, because every student is different, and that's why it's specially designed instruction. It is specific for that student's IEP. But guided math practice with mnemonics, getting them, especially songs. Kids remember things through songs. That is huge. So if you can tie it back to a song, Schoolhouse Rock used to have multiplication tables, and they still do. You can find them on YouTube. My kids would remember the songs, but then it is teaching them to use that song to put it back on paper. Of course, guided practice and chunking, that's a huge one too. And then explicit instruction. Explicit instruction is the I do, the we do, the you do, and more importantly, it is stepping through each individual step that student needs to understand it. And of course, we look over here and we see extended time and those kind of things. That's what this SDI, that's the supplementary aids and services that can be provided through that. All right, assistive technology and mathematics that you may be needing to use. Now, some of these, of course, a math line or a number line. It's just my opinion, but if you're doing mathematics of any sort, there should be a number line or at least a graph on every student's desk, to where they can have the coordinates, those kind of things, and they can use them every day. But a number line for our younger students is extremely important, and it doesn't have to start at 0. There are numbers before 0, so keep that in mind. Enlarged worksheets or worksheets that's been cut up. It doesn't take a whole lot to run through and just cut out the first 5 of the problems, and that's all that student gets. And then after they've completed the first 5, you hand them the next 5. So that's something that may need to be done too for that student. And then, of course, we're going to talk about calculators. We have, of course, the talking calculators, talking watches for students who have visual issues. But the big thing that I want to talk about is just the speech to text that you can get into for our students, and being able to get that if they're doing something they're having to write about. So these are just a few that are there for assistive technologies. These are general guiding questions, and they all relate back to our math practices. A few minutes ago, we talked about them being able to, they become frustrated and they kind of just stop. Well, your very first math practice is making sense of a problem and persevere in solving them. So if they become frustrated and they stop, what does that really mean? And these are some questions, and I'm going to send out this PowerPoint to everybody who signed in today. So you'll have these questions with you. The other thing is making sure that they can reason abstractly. But to be able to reason abstractly, many times we had to have visual models. We had to have symbols. We had to have Manipulatives are the concrete materials that they need to work through that. Again, this is the CSA model. And then, of course, construct a viable argument. I have some cue cards that I do that's got these on the front and then the questions on the back. These are really important for our students. And if you want a copy of those, please feel free to email me because I will send them to you. But constructing a viable argument, can they truly look at something and say, that's reasonable? That's a reasonable answer for that. And why is that reasonable? The other thing that we want them to be able to do is to look at it and say, that don't look right. I don't know why, but I can do this part of the problem. Or I understand my answer is 2. Maybe they wrote down 2 for an answer. And the question was 3 plus 4. So if they wrote down 2, and then for them to understand, well, 3 is farther on that number line than 2, this can't be reasonable. So at this point, they stop. And they say, okay, that's not the right answer. So being able to reason through or critique something. I loved it when my students, I would make mistakes in math and they would be like, that's not right. And they could pick out my mistakes, because then at that point, we're actually completing this part of the practice. Modeling with mathematics. How well does the student apply math to solve problems in everyday life? That's another key point for our students. Is it everyday life? Are we relating these back to those kind of things? And so for making sure that we're doing these, but this is what we want to get through for our specially designed instruction. Am I providing that instruction to where they understand the reason they're going to use this mathematics? And then, of course, using appropriate tools. Many times our students can't apply that. And it's kind of like when you hand them a chart and you say, these are, and I love this because when we do testing, they provide that wonderful chart that's got all those formulas on it, but our kids don't know how to use it. So we need to think about, how do I teach them to use the appropriate tools? So how do I get them to understand when to use the graphic calculator, when to use a protractor, when to use certain manipulatives, how to use the number line? Those kind of questions are what we're wanting to ask ourselves when we're looking through this. And of course, attend to precision. Is it accurate? Do they understand what the graphs and the quantities and stuff is saying? And do they even understand the symbols? We might use color coding, that all of the addition symbols are in black, subtractions in red, negative numbers are written in red, and they can go back through and do that. It could be that division's blue or green, so they underline that part of the problem. It could be multiplications done in bright yellow, and that helps when they're sequencing a problem out. And then, of course, look for and make use of structures. Now, in this one, decomposing a number, place value. Place value is huge for our students and they need it every day. So making sure that they can do the place value that's needed. And then, of course, do they know patterns? If not, please go back. Teach patterns daily in your classroom. And it can be as simple as skip counting. But not just skip counting as in 2s, 5s, 3s, and 10s, but skip counting with starting at a different number. So let's say we're going to skip count today by 2s, but we're starting at 5. So they're doing all the odd numbers. Oh, we're going to skip count today, but I'm starting at 10. And we're going to skip count by 3s. And so they do that. But not only can you do it forward, but you can do it backward, and making sure they're doing both. And then, of course, that falls right into that repeated reasoning and those kind of things, which, believe it or not, if I'm skip counting in elementary, that falls right into function tables later. And so if you've got a student who's in high school who's having trouble with function tables, we may have to move back and make sure they understand the skip counting part. And then students with a disability, have difficulties in these areas. Of course, coordination, That again, organizing things and organizing stuff on a number line, writing and spelling, that can be taken care of with a word bank for us. Note taking, of course, again, note taking, we can provide parts of the notes and we scaffold that out to where they're just filling in. Studying, understanding how to study. We don't teach our students to study. I remember going to college and I had been taught in high school to create note cards and to study from my note cards. One, the writing helped me to remember it when I was filling out my note cards, and then two, how to go through my note cards. So teaching our students to study, what's going to motivate my student to not just a grade, but what else is going to motivate my student? Tying this back to the real world. What are the motivations for my student? Do they want attention? Are they not getting not getting attention drawn to them? For some kids, they don't want your attention. They want to be left alone. They want it to be quiet. They don't want you to know things. So not getting attention drawn to them may be another reason why. For some kids, they don't want others to know that they don't understand something. So they act out or they avoid. And one of the ways to do that is if I'm disruptive, I may get sent away or I may get sent back to another classroom. And in those cases, that way attention is not on them. Again, power. Kids need choices. And sometimes that's their thing. Their motivation is power. They do this to feel encouraged. So they act out or they do certain things. So changing that around and giving them a choice of things to do can sometimes provide that. And then, of course, frustration. Is the student overloaded? At this point, like I said before, this can easily be taken care of. If I'm overloaded because of how much information is being given to me, one of the things that you may need to put in the IEP that they'll only be given a certain amount of problems. I don't want to frustrate them. I don't want to overload them. So they're only getting 5 at a time, or they're only getting 10 at a time. And for some of my students, if they were just provided cards and they were told that they could work through those cards, I noticed that they would sit there and work all 30 cards I'd give them. But if I gave them 20 problems on a worksheet, they'd automatically shut down. So thinking about those kind of things when you're writing your IEP is huge. Of course, their lack of knowledge. Do they truly understand the content and what is asking for them? And how can I break that down even farther? And then, of course, their lack of interest. Does it motivate the student? Have you incorporated them into this? Again, bringing back real world. How are they going to see this again in their lifetime? And then typical SDI for mathematics that we choose all the time. Direct instruction, right? Use of the calculator. Guided practice. We guide them through. One of the things we do is we guide them through a couple. So we work through examples, right? But we don't provide them with a worked example. Many times that we have at the top of the page or even at the beginning of the book or the beginning of a lesson, there'll be 1 or 2 problems that are worked out. Typically that problem is not the same all the way through. There's different steps in that lesson. There's different things. So kids get confused or they forget to go back. Again, this is where teaching them to study is extremely important. So study skills and that part of the SDI of teaching them to study is a huge part because now they know to look back. They know to go back to and see that problem. Work it out similar to that. What parts are the same? What parts are different? Those kind of things is extremely important for our students. But teaching our students to look back at a problem, break that problem down and study through that problem and then move on is actually a very high level strategy for our students to have. How many times have you had to work through a problem and thought really hard about it and went back to the example and said, okay, this example is set up this way. How can I set this one up to look exactly like this example that's been provided to me? So if I am going back and I'm looking at that example, how can I do this next problem? We need to teach our kids to do that. And then, of course, alternative math strategies, being able to decompose those numbers and have an alternate way to do things. Or teaching multiple strategies. Many times what's good for me for a strategy, and I can put that into my working memory, and then I can put it into my long-term memory, and it becomes automaticity for me, is not the same as what, I'm going to use Chastity as an example. She's going to love me for this, but is not the same as Chastity may use. She may need to be able to look at it place value, where I can just look at the whole number and be able to see that place value, but she may have to actually break it down. It is per student. And of course, visual prompts. Visual prompts can be in a journal. Visual prompts can be provided to the student at the desk. Visual prompts can be a word wall. So those are all the different types of visual prompts that we can have for our students. But the key to that is, specially designed instruction for that, is how do I teach the student to use those visual prompts? Again, it can be cue cards, like I said, at the desk. It could be a chart that they keep at their desk in their journal. It can be that word wall, but how have I taught them to use that? And then, of course, graphic organizers, the same. How do I teach them to use that graphic organizer? So, assistive technology with mathematics, these are some that I know you've seen. Desmos, the online calculator. All of our students are using that one. Make Math Digital, the little equation one, it allows them to see graphs and those kind of things. Another one is NCTMs, Illumination. There's all kinds of resources in there for you to use, and also virtual manipulatives that are on the National Library. These are just some different ones. Graspable Math, the geometry one here, I always mess that name up, so I'm not going to even try. But that's huge. But graph paper to assist with number alignment. How many of you have thought about using graph paper and just having the students to put one number in it? This is great if you're teaching a student to use decimals. And so one of those is actually the decimal. Decimals get aligned, right, for addition and subtraction. And so they can use that and put the digits in it around the decimal. This gets them started so they understand how to align. Same thing for writing just writing numbers and seeing what they need to do, because some of our students need to write this big. But if I turn the paper, if I turn just a regular sheet of paper around and I say you have to write it within those lines, the number starts to shrink. So just turning the paper around sometimes for our kids is a big thing. There is a UDL tech tool here, and this is the math tools, and these are just a lot of different ones for telling time, for visual math. As you can see, Glencoe has one for K8. There's other ones on here that you can use. I love this real world math using the Google Earth. Our kids love to see that kind of thing. And if you've got a kid who's into social studies, loves social studies, this is a really good one to have because you can tie it in. And then, of course, Sumdog Math down here for games. Really great ones. Strategies for teaching students with disabilities. One, avoid the memory overload, right? Now, when I'm talking about our memory overload, we have very short working memory. We can only hold so many pieces of data. Our kids are the same way, but it's even smaller. There's a reason why our telephone numbers are 7 digits, because that's about as much as we can hold. As I'm getting older, I can't hold that many. If I'm having trouble, can you imagine what it's like if I have a processing disorder or if I have a working memory problem? For our students, how do we take that away? Think about, how do we take that part? What specially designed instruction can I provide for my student to where I'm taking that working memory overload away? How do I take away the part of the retention of those things? Journaling can be one. They have a journal they can look back through. So, and it may be that we provide them with the instructions into that journal, or in that journal that they're putting the stuff in, they only put certain parts of the information in, and it's the real important parts. This becomes part back to you as a special ed teacher is, what are the important parts I need to put in? Now, of course, I'm just going to let you read through these real quick. Are there any strategies that are not here that you provide for your students to help them with their disability? Because you guys are all experts. You're really good at your jobs. What do you provide for your students that allow them to access the curriculum? Just give everybody a few minutes to think about other things that you may use. I utilize task cards. Task cards are really great. And one of the things that does is if you're using a task card, we're working on one task card at a time. And the fact of the matter is that is less cluttering for that student than a worksheet. Again, I said, if you're going to use worksheets though, teach the student to fold them over. They're only looking at certain problems at a time. And have them to progress monitor. If I use task cards, another thing that I do is I provide them with little sheets that they can go through and put their answers on. That way I can go back and check them. Sometimes I even number task cards. Those are important too. All right. So strategies that we're going to discuss today. Now, these are strategies for SDI that we're going to discuss. One in vocabulary, and I can't say this enough, but vocabulary is extremely important for our students in mathematics. Nowhere. Chastity's got reading and writing, and she's got vocabulary kids use every day. But I can guarantee you that what we say in math class is only used in math class. There is no point that you go out and start talking about add-ins or quotients or 90% of our vocabulary. So the only place that's used is in math class. So teachers, it's on you to make sure you're using that vocabulary every day. It's on you to make sure the student uses it while they're in math class. That's the only time they're going to get this math vocabulary, when it's content specific, especially like it is in math. A lot of the things that we do in science, they may still use that vocabulary in everyday language. Some of the stuff that they do in social studies, they may still use in everyday language. But the word sum in math class is different than sum that we use in our everyday language. So that's a problem. So how do we make sure that the strategies our students are getting, the explicit instruction in that vocabulary, is something that they are going to really hang on to? So that's going to be my first thing is talking about. The next thing is what explicit instruction or what can we use that's explicit instruction or an SDI in math for word problems, for just problems in general. So worked examples is one that I'm going to show you. I'm going to show you the CSP, content scaffolding progression of word problems. And we're going to talk about color coding and highlighting. So let's get started with just the Frayer model. Well, actually, let's take a moment. And I want you to think about the practice activities that you provide your student before we ever get into this. What are some practice activities or worksheets, whichever one, that you provide your student, and how is that organized? Take a moment to just think about that and write it down. Put it somewhere in your head, put it somewhere. How are they typically organized for mathematics? And I want you to focus specifically on a sequence of problems. And how do you present that vocabulary? Think about those things. One, how is my worksheets, my task cards, whatever it is, how is it typically organized? And how do I focus the vocabulary inside that for my students? How's that presented? How do you set up your problems? 90% of the time, if you printed off a worksheet or you printed off something and you're using them, unless you're using task cards, and many times if we just printed off task cards online, they are set up in a block format. which means the student does the same thing over and over again. And they are not having to really think about the process, right? They do the first one, and the only thing that changes is the number. So it's not shifted around. So the student's really not having to think past the first one. Now, this is great for initial learning. We want our students to do that, right? We want them to have that initial learning to where they're doing the same thing over and over again. So we put it into their brain. But after the first 2 times of doing a block format like that, we need to kind of mix it up, because then they have to really pull and think about it. So keep that in mind when we're working with our problems, that we need them to not always be in a blocked format. Now, I know we didn't think about that always, but it's very true. And for our special needs students, that's extremely true about them. They need a little bit of switch up, because they'll get into that pattern and they continue going on with that same pattern. And if we don't switch it up and we don't provide them with different types of problems inside of it, they get into a habit of 1 or 2 and they think that all the problems can be done that same way. So we don't want that to happen for our students. So providing them with a little bit of a switch up is a good thing. Now, the other thing is, and that, like I said, back on that, how do we provide them with a vocabulary? One of the things is, this is really hard, but sometimes teach your students to whisper. And when they go through, they can say add-in, they can say product. We want them to actually voice through the problem. This is especially important when they're doing a word problem. So having them to use the vocabulary and the terms is extremely important. Okay. Now, next thing, explicit instruction for math vocabulary. You as the teacher will select the word or the words. Don't choose more than 3 for our students that they are going to need to know. We're going to put them, you are going to put them in a student-friendly explanation, right? Again, this is not the student choosing this. You are putting it in a student-friendly explanation. And the reason why you are doing this is there's parts of a definition that students will leave out. So don't have them to create it. You need to create that. And then, of course, develop examples and non-examples. Again, examples and non-examples are huge for our students. Okay? They need to know, one, they can tell you characteristics based on an example. And then what characteristics should it not have based on non-examples. And then, of course, design a lesson that actually brings the vocabulary back in. Typically, a student to use the vocabulary like they should will need 10 exposures. I just said a typical student would need 10 exposures. That means our students will need 20 or more exposures to that vocabulary. So when we talk about math, vocabulary is a big key issue that we have for our students. They don't understand. They don't understand because they don't use the terms. Also, they don't know the terms to the symbols. So making it a key thing for them, having that word wall that has all of that on there is extremely important. And then, of course, you're going to have to augment that vocabulary instruction throughout all of your lessons to make sure that the student retains it. And again, as teachers, we are key in mathematics, because if we're using the language, we're having the students use the language, that's the only place they're going to be using it most of the time. We're not going to be using it outside math class. Explicit instruction for vocabulary. Vocabulary needs to be clear. Okay? You're going to say, this is, we're going to talk about the vocabulary of this lesson. And we're going to make sure that vocabulary is very clear for the students. They're going to have the ability to present the word meaning and examples and non-examples, and they're going to have multiple exposures to the word. We're going to have sufficient instructional time to use that throughout the lesson. Again, I'm going back over this because if you're talking about explicit instruction and explicit instruction in mathematics for vocabulary, we really need to make sure that the student has that time to do this. And then, of course, actively engage in the vocabulary. Have them draw you some examples and non-examples. Circle. Draw me a circle. Student draws a circle. Draw me something that you see every day that may be that uses a circle. So they draw a clock. And then say, what's a non-example of a circle? And they'll draw a square. They'll draw a triangle. Why is that a non-example? And so go back into the fact of why is that a non-example? And they go in and they actually talk about the characteristics of that circle. That's how we know that they understand what a circle is. Geometry is the one place as math teachers that we actually teach vocabulary. So keep that in mind. That's the one place we truly teach vocabulary. But we have to teach vocabulary throughout the math lesson. What is a sum? Well, I use some of that. That's not the same as sum in mathematics. The sum is the answer from two add-ins. And we talk about that with our students. Well, what's the two add-ins? 2 and 3 in this case, 3 and 5. Oh, it's 2 apples and 2 bananas. I have the sum of 4 fruit. So they talk about those kind of things. Again, this is the Frayer model. Now, in the Frayer model, very similar to explicit instruction, and you can use the Frayer model with explicit instruction because it has all the same things. So again, if I'm doing explicit instruction in the Frayer model, I have this, a student-friendly definition, again, generated by you as the teacher. And again, the term is going to be selected by you because you may not use all of the terms at that point in time that's in that lesson. You may just choose a few for your student to really remember because these are key for them. And then we're going to provide characteristics. These characteristics are the features of that term. What are the features of it that I need to know? And then, of course, an example and a non-example. If you have a student who has issues with writing, provide most of this, leave lines in it, and have them to fill in. Definitely have them to try to draw or find and glue in some examples and non-examples. This is important for our students. Being able to see those is extremely important. So different ways that you can modify this if need be. Now, nowhere did it say that I had to start with definition. Nowhere did it say I have to start with definition. Matter of fact, you can start with, give me an example that you know of a square. Well, if I provide a square here or a rectangle, whatever it may be, at that point, I can go back and I can look at, so let's say that we use the word rectangle. And I say, provide me an example of a rectangle. Well, what do you know about a rectangle? Let's look at it. It has 4 sides. Okay, that could be one of my facts about it. Are all sides the same? Nope. Are all diagonals the same? Yes, they're congruent. And then you could say, well, what do I know about it? Well, all angles are right angles. Therefore, it has the sum of 360 degrees. We know that the area is the length times the width. Those are things that we know. Now I can use this information to provide a definition. It's a 4-sided polygon because it's closed, right? All straight lines. And it has 4 right angles. Now, what are some non-examples? And the student can draw different non-examples. One of the things that I like to do with this is I take this Frayer model and I take this part out and I create another card with that. Now I've got all 4 of these things on there. I cut these up and I create a matching game with it. This is one of the things that you can do to help your students. Now they're going to match the term with a definition, with the facts, with examples and non-examples. Or it can be, you just want them to find the term and show me examples and maybe the facts or properties of it. And then it can be just as simple as I take the term and I provide a definition. Multiple ways that they can do that. This is one of those things, like I said, it's again, explicit instruction into the Frayer model. You can scaffold this in many different ways. Where do I start? Do I provide them with examples? Do I provide them with all the facts maybe, or the properties of it? And then they can fill in. So scaffolding that instruction along with it is part of it. Online vocabulary that you can get now. People, I love this Granite School vocabulary cards. I'm going to click on it real quick. If you go here, it's through 8th grade. Well, it's got secondary math list here too. But I'm just going to click on one. So here's vocabulary cards. If you look at the vocabulary card, it provides you with examples and look at here, and definition. Again, examples and definition. These are wonderful and they would make a great word wall for you. So this is one that you can use. Going back, Enchanted Learning. Enchanting Learning, excuse me, has a list of all the words. So you can go to their table of contents and you can find all their words that they have so they can use them. And there's different activities down through here that you can find. Another really good one. This is a great word wall for your kids. Learner's Dictionary. So they type in acute angle. Well, it didn't like that one. Let's do acute. Here's acute. And it provides them with all of mathematics and acute angle compared to obtuse. And so they can go down through here and they actually find the word and they just have to type it in, like this one. And then, of course, how to pronounce a word if they have trouble with it. Type it in. They can listen
acute.
They can listen to it. So again, these are really good.
Acute.
For a student if they don't know how to pronounce a word. Now going back, like I said, these are just a few, which I really like. I'm going to go ahead and take these off the top because we've got some more that we're going to do. But these are things, again, they have to be instructed to do. SDI is all about that instruction. So are you going to give them instructions on how to use vocabulary cards? Are you going to give them instructions on how to use maybe pronunciations of the words? And so the site in which you're going to, which is How'd You Say, are you going to give that, provide that instruction? Now, SRT is Scaffolded Reasoning Task. Now with this one, in a scaffolding reasoning task, can be verbal or it can be written, and you give the student a topic to verbally reason or write about, and you provide 2 to 3 essential math terms that they must be used in their verbal response or the written statement. Now, and you provide the terms. These terms should already be discussed. They should know them, and you help the student assess and engage in the activities. Okay? So if I'm doing the scaffolding reasoning task at this point, and this is Paul Riccomini, he does a wonderful job with doing research for us in mathematics. And this one here, he's done 3 to 5 years of research so far for our students Again, this is about providing the students with 2 to 5 of the terms that you want them to use, and how do they create an open response after being provided with those. So simple, a word bank. Again, it's instructional scaffolding that we're providing for them. One of the things that he recommends is that we use a rubric to grade it. Now, I thought that was a wonderful idea. So he said that he uses a 5-point rubric. 2 of the points is that they have to use 3 of the words, at least 3 of the words. Now they use 5 of them. So 2 points is that. 1 point is that they use those words correctly. And then the last 2 points are, is that long enough? Do they provide all the information they needed to about whatever topic it was that you were asking about? And so he says 3 to 5 sentences. Now, for your younger kids, it could be that they provide an example. So for some of your kids, it could be different things. So look at how you could create that rubric. And again, that's another way for you to measure, do they understand the scaffolding reasoning task? In the case that I was thinking today is I've been teaching fractions. I want them to use denominator. I want them to use numerator. I want them to think of unit. That may be 3 of my words, right? That I really want them to provide. Fraction may be one of those. I want them to think of the word whole in this case. So those are 5 of the words. And I say, I want you to write down everything, because I'm leaving this wide open for them, that they can remember about fractions. And I provide those 5 words. Now, I've provided them with those 5 words. Scaffolding that out. These are the 5 words I want. You got to use 2 to 5 of them, or I say you got to use 3. I use 3 of the 5 words. And so the student then tells me what they can remember about fractions in a writing. It doesn't have to be in a writing. I can provide those words and say, now verbally tell me what you know about fractions. I've taken that writing part out, but it's a verbal tell. Now, for most of us, we've got technology at our hands, so they can verbally tell and record it. 2 to 3 days later, we went over this again. Verbally tell. Now, what's the difference between the first time you told me and now? What did you remember? What was extra that you added? Those kind of things, just talking through them. SRT scaffolding reasoning task, there's key features to make it effective. 1, pronounce the word for the student. Again, I gave you an option to do that on how to say for the student if they needed it. State the definition and have the student repeat the definition. Again, our students need multiple ways and multiple exposures, and they have to do it. Students have to model the math the same as we model the math. So if I've got manipulatives in my hand, they should have manipulatives in their hand. Another thing for this is same with words. If I give a definition, I want them to repeat it back. We're going to become little parrots for a while, and that's okay. Making sure that we are provided with good examples and non-examples. In this case, bad examples. Sometimes our kids need to understand, nope, that's not a good example. Also, if they're doing a writing example, I love to take the writing, and I don't say what's wrong with this writing. I say, what can we add to it, right? If I'm providing a writing piece and I want to say, guys, this is a really good example of a writing piece, and maybe I've provided that one. And they look through it, and we talk through it. Did it hit all the key components I was asking for in this writing piece? Same thing in mathematics. Or does this hit all the components that are needed when working through this equation? And then I provide another example. What did they leave out? What did they forget? Did they follow through on the steps that they were supposed to do with the mnemonics that we've just done? And maybe they don't. So keeping that in mind, that when I'm providing these, it's the same thing with a writing piece as it is with a problem. I'm going to provide them with, did we do all the pieces? And then, of course, review any new words for our kids for mathematics. Make sure you're reviewing them. And previous learned words need to be brought into it also. Now, they've been taught whole numbers. They know what whole numbers is. So when we talk about whole numbers in comparison to fractions, they should understand that part. So they're going to bring it back out of their long-term memory. And then, of course, teach the word within its context. And in mathematics, we're the only place they're seeing it. Now, cue cards, reference sheets, and we know that they are provided with reference sheets. We know that during parts of the test, they are provided with reference sheets. That is overwhelming if they have not seen those same things. So go back again and explicitly teach how to use my reference sheet. When would I use this formula? What does it need to say in it? When would I use this information on the reference sheet? Talk to them about those kind of things. Word walls, them knowing when to use and how to use their word wall. Like I said, I like word walls that also give examples. I like word walls that give me the ability to have the definition to it too. That helps us in mathematics. And then, of course, word journals. If they have a journal and you can use the Frayer model, they can create the Frayer model by just folding a sheet of paper. And then they just label it. Believe it or not, our kids can most of the time fold paper, and they like folding paper. So have them to fold the paper and create just one real quick of the Frayer model. Nothing that you have to do. This right here is an article on cue cards and how to use those in mathematics. And it's a really cute little article on cue cards. So how to use those. Again, you're getting this PowerPoint. May not be at the end of today, but you will get it by tomorrow once we go through and do that. All right. So next thing, math vocabulary. I'm just going to go back over it real quick. We talked about the SRT and the Frayer model. They're very effective. As teachers, you play the biggest role in mathematics language. They don't use it outside of your classroom most of the time. So keep that in mind. And understanding essential math vocabulary is essential for our students to be proficient. Right now in the state of Kentucky, we have a 14% proficiency rate with students with disabilities in mathematics in 8th grade. 14%. A big key part of that is students understanding the mathematics and being able to walk through the problems and understanding what's being asked of them. So that's the reason why I really focus today on math vocabulary, and I'm focusing on how to set up a word problem. Worked examples. This is critical for our students. Worked examples is very high on a Hattie's effect size. It's like 0.72 or something, but it's extremely high. So we want to make sure that we're using worked examples for our students. One, a worked example gives the students a pattern that they can use, right? And for SDI, if we're providing worked examples, we have to actually do the instruction on how to use the worked examples for our students. So mapping, it gives them a chance to map through similar and different problems. Again, it's a study technique too. And can they go from surface learning to structured learning easily? That's what worked examples provides for us. And we focus on the structural aspect. That is the underlying concept, not just an answer. Many times the answer is provided in a worked example. We're looking for, how do we get there? That's a big problem for our students when they're working through a reading problem. They just want an answer. They don't understand what's being asked. What's the underlying part of it? How do I go through the process? They just want an answer. So now we have to kind of stop that. Now, why do we use worked examples? Well, we have a limited working memory, and I know you've heard me talk about this already. That limited working memory can only hold so much. I'm taking that part out. If I provide them with worked examples, I'm taking that part out. I'm taking that limited working memory capacity out of the equation. And now we're going to focus on what is really important, the concept inside of the math problem. And it will provide my students at some point the process and understanding the schema of the problem, and will develop into automaticity. That is huge for our students. I'm sorry, guys, they're weed eating outside, and I know you can hear it. All right. Worked examples are not the same as working an example. I cannot tell you, if we work an example with our students, that means we're going through step by step. A worked example is already done, and now we're going to study that example. So we're teaching our students to study. Again, this is part of the SDI, specially designed instruction, to teach our students to study the problems. Now, there are different types of worked examples. We have correct examples, we have incorrect examples, we have parallel examples, and partially completed examples. Partially completed examples. I'm going to say right now, we always start with correct examples. Then we will provide some incorrect examples. We will move on to parallel examples where students are comparing, and then we'll do partially completed examples. Now, I would do correct examples, partially completed examples, incorrect examples, and parallel examples. Now, a correct example is this right here. I've provided this to the student. We've looked at it. We've talked through it. Half of 12. And we talked through that. Now, what do you need to do to set up this problem? And we talk to our students. Now, I've probably already at this point, because this is all abstract, I have modeled this multiple times, half of 12. And so the student starts breaking up half of 12s, right? So what is half of 12? And they break it up and they see it. It's 6. And then we talk through this problem. What can I simplify? And we talk about that part of it. And then I say, there's always one big thing, and that's the questioning at the end of an example. In step 3, why do you think she changed the 12 to a 6 and the 2 to a 1? And at this point, they're going to stop and they're going to be, oh, well, she simplified. Well, how come she could simplify that? Well, 12 divided by 2 is 6. Or the student may say, well, I know they're both even numbers, so 2 will go into 12. That could be one of the things. And then we can talk about that. And then, of course, we're going to provide the student with one that they're going to do themselves. And we may even walk through this one with the student. And so the student will complete the problem in the same thing. What did she do here? Looking back at this problem, what do you need to do? I need to, at this point, change the 16 into 16 over 1, or I need to just go 1 times 16, put the 4 on the bottom because that's what we did over here. Those kind of things, talking to the student through this. And so the student works all the way through the problem. Is there anything you can simplify? And they do it. Incorrect examples. If you can look at this one, again, make sure that the student knows this is an incorrect example. Now, with this one, I would talk to the student and I'd say, okay, there's been a mistake that's made. It's incorrect. And I make sure that they're like, okay. And I said, just kind of look at that. And we're going to just look at it and we're going to correct it on here. And so the student would be like, well, 39 is, and we may even talk about that. What do you think that the mistake is? And they would like 3 plus 9. There's no plus in between the 3 and the 9. Or there's no addition sign between the 3 and the 9. And so they'll be like, I say, so what should that be? Can we build that and model off of that so that you know? Well, let's build 39. What should that be? 3 10s, 2 9s, so that's 30 plus 9. And then I can say, okay, so if 3 plus 9 is wrong, what about the 56? What should that have been? And we can talk them through it. And then I'm going to say, okay, now here's your problem. How would you do that? And so they will go ahead again and match it. But again, it needs to be labeled incorrect. They need to know there's a mistake and they work through it. This would be one of the last things I would do with a student. I would definitely go to maybe a partially completed after a correct one. Now, again, what do we want? Those questions at the bottom. We want to make sure that the student can verbalize what they know. What mistakes did Jill, in this case, make in line 2? She didn't break down the problem. She didn't decompose her numbers correctly. And so we can talk about that. What should she have gotten when expanding the numbers in line 2? And then, how would you explain this mistake to Jill? If a student can explain it, they understand it. Again, it's kind of like if we can teach it, we understand it. So that's big for our students. Now, a parallel one, you can do a correct and an incorrect side by side. Talk about why they are. One was correct. Why is one incorrect? What was the mistake that they made? I love this one because this is -20. And for many of our students, understanding that I have 30 and I'm taking away 50, I'm actually, we use money, right? We use money for a lot of things with our special needs students because one of the things they understand is money. So if I have $30, but I owe you 50, how much do I still owe you if I give you my 30? So that's going to be a -20. One of the things that I do is I have my kids to color code that. It's going to be -20 is going to be in the red. And they understand being in the red on a bank account. That's the other thing. And then, of course, those questions that they need to answer down there really gets them into talking. And you want to be very specific about your questions that you're going to use. The next thing, parallel examples can be done, correct and incorrect. Again, this is with older kids. And this one, I love the fact that it gets into setting up the problem. How did you set up the problem? Do you remember how we set up a problem? What do we always say about that problem? Well, on top should always be quizzes. On the bottom should have been weeks. So they have to be the same on top and bottom. My kids will think that through. And then what did they do that was wrong? This is a correct and a correct. So in this case, is it any different that the student decomposed the numbers to 240 and 6, 120 and 5, and then added them up? Is there a problem with the way that Jack did it? When setting up the problem, what did Jack do first? Does his answer make sense? Those kind of questions is important for our students. Does it make sense? Did how Katie set it up, did it make sense? Was it, which one was more helpful? Those kind of questions can be asked. This is a partially completed example. Now there's a lot of color coding going on here, and I love color coding for our students. But I like this because line 1 is color coded for each student. Line 2 is color coded, so it's easily and visually aesthetic for them to go across. Line 3 is color coded again, and then line 4, and he can see what parts do I need to complete. The good thing is I can look at Jane's, and these are all completed and they're all correct examples. I'm just filling in, and you'll notice the questions are what factors and products are missing in line 3. And so the student would go back again and look at the factors and the products that are missing and what they need to do. All right. And this is set up in the area model. So this is going to be a 2. 2 times 10 is 20. 2 times 5 is 10. In this case, what's missing up here? The 26, the 2, and the 6. So they've done this area model before, and they're just going back in and filling in. Now, at no point in here did it ask for the complete answer. What a thought. We're just looking for the process. All right. Steps in creating a worked examples. 1, set a goal. Students need to understand goals for themselves too. Okay. But for you, you're setting this goal with the students' errors in mind. What errors do they typically have? You're going to create these problems to alleviate that error. Select the type of problem you're going to use. Make sure that you start out with correct and you move into incorrect, or you move into a partially completed problem and then an incorrect, but always start with correct so they can see the right way to do it. And then select prompts that you're going to guide, self-explanations that you're going to do that's going to help guide them in the questions. Now, our next thing that we're going to talk about is CSP, or Content Scaffolding Progression. Take just a moment and look at the problem down through there. Tell me one thing that you noticed about that problem on this side, the scaffolding problem solving. Look at it and tell me one thing that you noticed about this problem here compared to this problem here. And let's put that in the chat. Think about what you've noticed. Now, this is content scaffolding progression. This is one of the things that you can use for an SDI, because you're going to teach them how to scaffold a problem. Look about how I have set this up. I see somebody say that the answer is provided in the top one. Yes, it is. And we're going to talk about how to set this up for our students. This is really good when we're starting on word problems to get them focusing on what is the process rather than I'm just looking for answers. Because truthfully, I need to know the process. And this is what happens. Oh, I like that. The last one has a fraction in it. It sure does. So if I've taught fractions, I may throw that back in there. There's one here I messed up on. I actually put inches instead of feet, but we'll go back to that in just a few minutes. The very beginning is very teacher-led. And we're going to, at this point, I'm going to model multiple ways and everything. The very first one, I'm going to really model. I'm going to really show it. I'm probably going to get out my manipulatives and I'm going to say, you know what, there's multiple things we could use here. I'm probably going to use a number line to show it. I'm going to work through that. So if I say an oak seedling grew 10 inches in the first year, and every year after it grew 1 inch, after 9 years, the oak tree was 18 inches tall. One of the things that my kids would typically say for this, they would, and if I haven't told them the answer's in there, how tall is it? They're going to automatically just want to add everything up. They would throw the 10, the 1, the 9, the 18 in there, and they just add it all up. And at that point, we'd have to stop and I'd say, guys, where did we start? What's the start point in here? Who can tell me what the start point is for this problem? Anybody want to put your start point in? What's the start point for this problem? $10 inches, I see. So I started out at 10 inches my first year, and we could model this in just a number bar if we wanted to, or in a number line. So if I wanted to have 0 here, I know in the first year it grew 10 inches, right? And so we're going to do the same thing here. This is 10. Now, I think I lost it again, my ladybug, right there. So I'm going to draw this. I'm probably going, like I said, this is my CSA. I'm going to have this modeled here, first year. Then I'm going to say, well, what happened after that first year? What's my add-in part of this? What's my second part? And the students are going to say what? It grew what? It grew an inch, right? So it grew 1 inch each year after that. For how many years did it grow? And you're going to say for 9 years. So this is my first 2, 3, 4, 5, 6, 7, 8, 9. So they're going to go in here and they're going to put 1 inch in each one of these. Now, can they go back and count that up? Absolutely. 10, 11, 12, 13, 14, 15, 16, 17, 18. Do I have my total that is 18? So this overall total here, all the way to the end here, should be 18. I didn't have enough room. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be at 18. This is 11, 12, 13. And I'm going to model this for my students. A little bit better than that though. Now, in the second one, I'm going to give them some opportunity to do this. And you notice that it gets a little bit harder, right? I've modeled this, but it's a little bit harder. And at this point, if you notice what it says here, teacher is guidance is gradually reduced. Now, I'm still going to help, and I'm still going to do that think aloud. And that's extremely important for our students, is doing that think aloud. Man, for us to think and model through that is extremely important. So for our next one, I'm still, again, going to guide them, and I'll probably even read the problem. And I'll say, the oak seedling grew 25 feet in the first year. Can I use, again, this bar model maybe? Could I use a number line? I do not want them drawing a tree. I want them thinking mathematically. So I'm going to think about what can they use? What are some things that the student can use to do this mathematically? Now, I guarantee you, you'll still have somebody who will want to do that little tree, and here'll be the 10, and then here's 1, 2, 3, and they'll try to do that. But don't let them. Go back to what are some mathematical materials that you can use so that we can see this. And they're going to go back, again, probably to a number line if you've used number lines quite often in your room, or, like I said, the bar model if they need to. That's fine. So at this point, like I said, what can we use? Grew 25 feet in the first year, and every year after 5 feet, after 4 years. So again, if we look back and think about the last one, what did we know about that? Do I have a start? Absolutely. I have a start that's 25. So here's my start. Do I have something I'm adding? Yes, for 4 years. So this is 1, 2, 3, 4, and that's going to be my total. These are 5. So where did I get to? Is that 40? 30, 35, 40. Yes, that's 40. Now, what do you notice about the third one? What have I done at the third one? I added the question back in, didn't I? At this point, my student needs to know I am going to look for an answer. But now I'm also looking at the process. So that's what, and I will work through the third one with them a little bit, but I'm really releasing this to them. The question's been added back. And at this point, they're looking on their own for this. I'm trying to get this out of the way for us. Okay. Now, and of course, this one is the original question I probably started with out of my book. I just changed it a little bit. So this is my original targeted question. Again, this is one of those things that's recommended by Rick Amini. He does a lot. Like I said, he's done multiple years of research on this. And this is a very high effect size for our students. But it's called Content Scaffolding Progression. Now, I'm going to start with my original. And we do not have time as teachers to sit here and make up worksheets or make up PowerPoints that. So choose a problem you already have, go back, rewrite that problem, take out things that you know your kids are going to have trouble with. Maybe it's the name. You know, I may have a student in my classroom named Robert. So maybe I take out things that I know they're going to have trouble with. I make it more simple for them. I take out content they don't need. By the fourth problem, I've added back content that they may not need for the problem. I've added back the question. So the third step is the questions there. I may added back a little bit of information, but not a lot. And by the fourth one, I've added it and it's more complex and it's back to the original problem. So keep that in mind when we're doing content scaffolding. This is the way that we work through it. I want them to see multiple ones. Now, we can scaffold their homework for them so that they get back into understanding it better. I want them to really think about the problem and the order. In this case, I used order of operations. But I teach my students, again, to study, right? It's a scaffolding technique that I want to teach them. I want to teach them to study the problems. So again, we looked at up here, all these problems look the same, but then you get to the bottom one or the third one, and maybe there's something different about it. Maybe there's more inside of it. But I want them to have the opportunity to see how to do the problem. And so I did, as you notice, number 2, I gave them the opportunity to do a couple more. Number 1 in B is already worked. So I went down here and I looked at number 3 and I did that problem. I skipped over and I did number 5. I did number 7. And because it started with divide, and this one started with divide, and this one started with add. So maybe I needed to look back, and this one started with multiplication. Then I went down here and I did another one. So I worked through different problems. I want them to study through those problems. So what did Miss Kidd do first here? Well, and as you can see, I underlined and done those kind of things to give them some key points. Now, for our students, we have to talk them through it. We have to have them learn to talk through it too. So that's important. But scaffolding their worksheets that you're sending home helps. One, if I have a student who becomes overwhelmed with a worksheet, and they look at it and they're like, well, these are already finished. That provides them with the opportunity to say, I'm not having to do as many. I can look back and have an example from multiple ones. What did she do? And it's just ones that you've chosen. Now they're only having to do a few, but I can grade a student on how well they know how to do something on 5 problems the same as I can 10. All right, cover, copy, compare. Has anybody here used this? Just yes or no? You've used cover, copy, compare before. If you've been to interventioncentral.org, this is one of the big things on here that you can do. I love cover, copy, compare because it gets the students with fluency. Okay. Now, the way they teach it, there's a video, and like I said, I put all this on here for you, and you're getting this PowerPoint, but there's a video, and he recommends they just say it one time. I do a 3-2-1 with this. And the reason I do a 3-2-1 is because I want my students to really understand what they get it in their head. They have to get it in their head. So again, I'm pulling up the ladybug here because why is that not there? Let me bring this up. Give me just a second, guys. Sorry for technology issues. Okay, can everybody see my ladybug? Hopefully you can. All right, good. So if you notice, cover, copy, compare, you can go in and put these problems in. That's what I like. What I do when I'm teaching fluency and I'm teaching students to do different problems, especially multiplication or with addition, I choose 3 or 4 of the facts. I don't try to give them all of them. One, because it just overwhelms them. 12 facts is a lot, or 10 facts is a lot. So I'm just choosing 3 or 4, and they're going to get very comfortable with those, and then they're going to continue to redo them over and over again. Okay. Now they have some that are already made up that you can just print out. You'll see there is this line here, right? This line is important for our students. You can do them vertically and horizontally. That's even better. So if you notice mine here, I've got the same one on here multiple times. Now, did I change it around? Absolutely I did, because we have what? The community property, especially for addition and multiplication. Now, so I changed them around, but I have some that they already may know. So let's say that they may know this one, or they know this one already, or they know all their ones, and so they're comfortable with those. Those are ones they already know, and I will gradually remove those and add more. But cover, copy, compare, I love to use because of the fact that, one, they can fold this. This is a self-check for themselves. I teach my students to, guess what? To verbalize out loud in a whisper. So I'm going to verbalize out loud in a whisper these problems. And this is how this works. So the student touches them and they verbalize as they're going through this. 3 plus 2 is 5. 3 plus 2 is 5. They do this 3 times. There's a reason it's a 3, 2, 1 thing. 3 plus 2 is 5. And so they come over here and they write it down. And I try to give them something that doesn't have an eraser. And they'll say, okay, that problem was 3 plus 2 is 5. Now, they go back and they check. So I've written it. I check it. 3 plus 2 is 5. Yep, that's what I've got. Good. I can move on, right? I've done that 3 times. I did a check. I'm correct. This is where the 2 comes in handy. Next to 1, let's say I'm having some issues with this one. And I say 4 plus 5 is 9. 4 plus 5 is 9. 4 plus 5 is 9. Cover it up. 4 plus 5, and the student's sitting there and they're trying to remember, and they're not using their fingers or anything at this point. They don't even try, and they say 8, because I remember 4 and 4 is 8. And now we're going to compare. 4 plus, nope, that's not right. I'm just going to mark through it. This is where that 2 comes in. I'm going to do this again. So back to when I doing it. 4 plus 5 is 9. 4 plus 5 is 9. 4 plus 5 is 9. 4 plus 5 equals 9. You can say it that way too. And then they're going to cover it up again. 4 plus 5 equals 9. I'm going to compare. This is a quick, easy self-check that they can do. And they're going to continue down the page. Again, I want them verbalizing. I want them saying it. Doesn't have to be loud. Needs to be kind of quietly. We're going to teach them to whisper. And they're going to go through it and they're going to say, I should hear whispers. Math class should not be quiet. We have our time for it to be quiet and for them to be working, but most of the time they need to be verbalizing, and to verbalize, I need to kind of hear. So I tell my students, it's okay to whisper out things, to whisper out your process, whisper out your thinking. I don't know how many times we talk to her. I don't know about you guys, and maybe I'm showing my age, but sometimes I have to talk myself through something, and that's okay. Sometimes we just say things out loud so we can remember it. That's okay too. So getting our students to do cover, copy, compare is very important. Now there's some good things, like I said, about this. 1, the verbalizing. 2, it's going to provide my students with the ability to compare on their own by themselves. I do not allow them to have an eraser just to erase it. They just mark it out and they do it again. The reason why I do this is so that I can see, are they still having trouble with that problem? Sometimes it's just having them do it with pen if they need to. That's an easy way. It's an easy way to check. I can keep these sheets and we can talk through them. And then again, if I'm providing a fluency check later, then they can have those same problems and we're working through them. Another thing is I don't allow them to skip around the page. They start with 1, we end at 10. And I don't do more than 10. And many of these, again, are repeated within the 10. So keep that in mind too. Okay, so if you use cover, copy, compare, that's what it is. Again, that's my 3-2-1 method that you can do. That way it gets the kids really thinking about it. And it can be either way. You can do the horizontal or you can do the vertical. And there is a great little, if you want to use this for spelling, give Chastity a hint here for some reading. You can use it for spelling words too. All right, so word problems.
I appreciate that, Steph.
You're welcome. Yeah, word problems is a really good one. Spelling words is a really good one for that. So word problems and what we're going to use. First of all, manipulatives. We're going to use manipulatives all the time. I'm going to use a number line. I really believe, I don't care what the grade level is, students need to have a number line on their desk. I'm going to teach them to use the bar model. Okay. And I may even use different little figures if that's what the student is interested in. That's the way I get them started. I mean, but the problem is they got to be able to transfer that knowledge. So if I'm using some kind of manipulative, I will probably use a number line also, so they see it on the number line. Okay. Now this is important for our students because again, it is explicit instruction in that number line. It is important for our students to see the bar model. That way they're getting it. And again, you're teaching that bar model. And then of course, students will create word problems from number sentences. So now we're going backward. We're teaching the student to go backward. You've given them a number sentence. Now create me a word problem with it. And then of course, they're going to teach and identify we're going to teach them to identify the question. I didn't say a key word. I said we're going to identify the question. At this point, we're going to teach them also to maybe highlight that question. We are going to break down that word problem and identify the start, what happens next, and where is the ending going. That's the important thing about a word problem. We have a start, or maybe we don't have a start. We know that's the missing part. So what's the information I have and how can I put it back into the problem? And then of course, we're going to highlight the information in the word problems. I know there's so many times we've talked about keywords, and keywords are great. But the problem is with keywords is sometimes it doesn't make sense when you look back into the problem. It may not mean just all together. Or maybe when they see those keywords, they just go through and add them all up and you've been given the answer and you're looking for the beginning. So think about those kind of things when you're doing this. What is the process of the word problem? Now, of course, teach the students to question any directions or instructions that's not understood. That's huge for our kids because sometimes they just don't know. And they'll say, I don't know. I don't know. Well, where do we start? What part do you want to look at again? What part do you know already? And it can be as simple as, well, I know there's a little boy in the story. Okay, there's a little boy in the story. What's happened to the little boy? And you start going through it. But what information do you already know? It's a good place to start. And it can be as simple as he's got a red shirt on today, but getting them started. And then of course, color coding and highlighting. How do I use these? How do I use color coding and highlighting in my work. So I've got a couple of problems here. And we're going to kind of talk through these. So let me find my problem here. Lost my problem. Found it. Let me put it up on our thing. This is a carpentry task. So this could be something that can actually happen in real life. So we have this little task and she's going to recarpet her bedroom. So maybe you want to recarpet your bedroom. She has a bedroom that is 15 feet long and 10 feet wide. How many square feet of carpeting will she need to purchase? So she's going to go to Lowe's and she's going to purchase this. So we're going to just do some highlighting real quick. What do we know inside of our problem? I don't have highlighters, but I have some color coding that we could do. So what do I know inside my problem? Oh, I need a red. We'll just use this one. I could have my students to go through and we can just box in or put one color around all of the numbers if we need to. This is one way. Let's just do that. And then I can say, okay, let's set this problem up with underlining in a certain color. Just the question. And I could say for our older kids, because we want them to know, I'll say, is there any important parts for units? And maybe they're like, yeah, square feet. Like, is there another way to write square feet? And so right down below that, they may come and put feet squared. So they know that needs to go at the end. Okay? Because we've already talked about square feet and how to rewrite that. And so they're just going to go ahead and do that. Now at this point, I want to say, can you draw this out? Teaching our students to model it, whether it's I'm modeling it with blocks or I'm modeling this with a drawing, then yes, they can. And then say, okay, what do you know? Well, I know it's 15 feet long and it's 10 foot wide. This is not a good representation, but it's very similar to what my kids would probably do. And we'll say, okay, so we know it's 15 and we know it's 10. And some of your kids will literally draw out 10 lines, 15 lines, and have to count, right? I mean, some of them will do that. And that's okay. That's a strategy they have. Some of them will know to break this down into 10 and 0 and 10 and 5. They've done the area model. And so they know that 10 and 10 is 100, 0 and 10 is 0, 0 and 5 is 0, and 10 and 5 is 50, and they're adding it up. Some kids may be able to do that. Depends on what you've taught your students to do. They may be able to break up the numbers, decompose the numbers to be able to create that area model. If they can't and they need to draw it out and they go through and let's say that they've created this and they draw the lines across, they draw the lines down. The problem that you run into with this one is they miscount inside. You know, we want to do our best to try to show them how to do these models. again, that's back to the instruction that you're providing your students every day. And what's a different way that I can do it? Of course, again, you may have a calculator to where they're doing this problem too. So how can I teach color coding and highlighting? I will be the first one to say, as I got older for my students, when they, well, for younger students, decomposing numbers. 10s are one color, and they understand too, if it's 36, and I shouldn't have got rid of that. Let's just say it's 36 is the number. 36 is my number. 10s could be one color. 1s are another. So I say this is 6. We said this was 30. They're decomposing that number. This builds right back into that area model. And so they can do that. It's one of the things that we can have them do. Now, for my older students, negatives are always red. Positives were black. That's another way that we can do it so that they know. And then I can relate that back to the fact that they understand money. Negative means I owe that. So that's one of the ways that we can do this for highlighting and color coding. All right, how do I document SDI? One is our student progress data. If they are working through and making sure that you've kept their progress data, you're going to write somewhere on some of the things that you kept, what you're doing for that student. So what did you do for that student? And then at this point, so if we're documenting it, we went through, and let's say that on this week, I've done explicit instruction in the CSP for word problems, and they're working on word problems. And so we did that and they've done it. And then I put CSP, on these 2 days. Now we're going to do the progress monitoring for that word problem. They do it. That's not working. Okay. We did highlighting and color coding. We added that to the CSP the next week. It's not taking it away. We're adding to, right? That a way that the student doesn't have trouble with it. Some other things that you may look at is your lesson plans. Now, if you're co-teaching, when you guys sit down to make those lesson plans, what is that instruction, those high leverage practices and that instruction that you are doing? And make sure that's put back into the lesson plans. What are those things that you're providing to just those students? Somewhere that needs to be documented in the lesson plans. These students will need, and then they're going to get that. How are they going to get that? Maybe they're going to get that as centers. Maybe there's going to be a pull-out time. And I'm not talking about pull out to another room. I'm talking about a pull-out time to where they're in the back of the room. Those kind of things. Maybe they have resource time, and that's when you're providing those. So it's going to go in your lesson plans. So how am I making sure that I'm documenting this SDI? Make sure it's written somewhere, because like many things, if it's not written down, it didn't happen. And then I'm going to quickly, before we go to their feedback form, because I finished up kind of quick today, but one of the things I want to talk about is, let me stop sharing my screen. If you have this book, it's a really good reference book. If you can see my screen, this is a really good reference book. It's called the Teacher's Resource Guide. Inside, this is a staff development for behavior problems encountered in the educational environment. There's a whole section in here on just mathematics and what you can do with math calculation, math reasoning, and those kind of things, and things that you can provide. Of course, one of the things that I would suggest is you go through and you think about each individual student, what's going to work for them. If you've got this book, it's not real expensive. And maybe you can talk your districts into buying it to have as a reference inside your school. it could definitely be used for your students who are in tier 2, tier 3. Different strategies that they can try. Talks about breaking down word problems. It's got discussing words and phrases that the students may need. It also talks about use of a calculator involving word problems. There are many different ones in there that you can do for that. So this is for mathematics. Intervention tool directions is basically, this is set up with different tiers. I want you to see this, and this is what does good instruction look like. It should include the majority of these things. First of all, high ceiling task. Even for our students, the test doesn't change for them, guys, so the task still needs to be high level. It's how we break it down, that specially designed instruction that we provide that student to break that down is what is so important for our students, okay? And having that part, of course, you guys have heard me all day speak about the CSA model, and I could sing praises of it forever. That's a real important part of it too, getting the manipulatives inside the student's hands. And then, of course, the big ideas for mathematics is listed on down here. And of course, we have to talk about both hemispheres of the brain and what's those learning styles that they have. So that's in there too, and making sure we're touching on all of those. A big one is patterns again. Now, tier 2, I know I'm speaking to the choir here, and you guys are asked these questions all the time. I'm sure there are regular ed teachers coming to you guys all the time saying, what do I need to be doing for tier 2? Well, tier 2 is truly a smaller group of instruction. It's, students no more than 5. Like I said, a small group that they're working to for probably about 20 minutes, a couple of times a week. And then, of course, tier 3 is truly individualized. Shouldn't be more than 2 that's getting that instruction. And that needs to happen almost every day for approximately 20 to 30 minutes. Now, in mathematics, if there is a problem area or concern, you will see it listed over here. Now, we broke this down because guess what? I'm a special ed teacher, so I'm thinking, okay, in my head, I'm thinking, what are the 2 areas that we look at? Math calculation, math reasoning. Am I correct? So if we're looking at math calculation, what are the difficulties that happen in math calculation? I put those down through here. If that student is having a problem in that area, what are some things that they can do? An intervention, a strategy, something that we can provide for them. Now, I'm one of those people who I like numbers. So you'll see out here in parentheses the Hattie effect size of each one of these. So those have already been researched, and we know for sure the effect size that's on those, okay? Now you can go back through here and we'll look at each one of these. Direct instruction organization. Wow, one of the things we talked about today, they need to be organized. They need to learn to organize their numbers. They need to fill out charts and how to organize that information. They need to not only do that, but just organize their thinking. And then of course, we're going to look at on down here, over here is what's the evidence that says I've done this? And so these are some evidence things that you can use. And then how do I collect the student data? If you have not been on, well, there's several of them, but thatquiz.org, I'm gonna see if I can go to this. Thatquiz.org allows you to look at multiple things. You can create a free account. You can put your kids in, it gives you a code. They come back to this site right here. They put in the code, it takes them right to their test. It keeps that information and even graphs it for you. So let's say that I want to look at, we're just going to do addition. At this point, I can do simple addition. I can do addition and subtraction, so I'm mixing it up. But let's say we're just going to do simple addition. I can look at long. I can look at inverted, where it's missing the add end. I can look at triple if I need to. I can add negatives at some point. I can add parentheses if I want to. This is just with negatives. So we can see how we can do multiples. Now, I'm going to tell you, they've got lengths on here, but keep it within 10. Our kids really, you can change the level. It can be extremely simple. It can be extremely complex. So, and then of course, this has a timer on it. At no point do I recommend a timer. I know that we have to do fluency checks, but guys, that timer right there will put so much anxiety on you or on your students that is unreal. And then of course, can they have feedback? And yes, you can provide feedback. You can turn it on. They'll get feedback on them when they get their answers. Now, again, over here, this clock is here and it tells them how many they got right, how many they got wrong, and those kind of things. Again, if you're signed in, and I had this for every one of my students, and every kid had a different code, which was great. Or if I had 2 or 3 that had the same thing going on, let's say I brought them in and they were all working on simple addition, then they all had I could put all 3 of them together and they could have the same code. If not, and maybe one was working on subtraction and one was working on a multiplication, then everybody could have a different code and can easily be set up. So that's a really good resource for our students. Again, back to this tool. I'm just going to go through this real quick. The commit screeners are here. It's a great tool for your students to be able to have, because this gives you a beginning of the year, a middle of the year, and an end of the year for them to be able to use. I want them to look through it, and I want them to be able to do the problems and then see where they're at. And this is just going to be a resource for me for later. Again, on here, Easy CBM is there. That's another resource. You can pay for some, but there's a lot of things that are for free, so it's a good thing to use. One of the things that most people don't think about is color coding the clock. Also, by color coding the clock, you get into fractions, which is wonderful. And then, of course, if they're having difficulties with precision, one of the things I can do is turn the page sideways. This works great with decimals. This works great with having my students to write neater, to line and organize their thinking. But all these blue things here have some sort of extra thing that you can go to be able to either get print-offs or different things. Now, the next thing that we did for this was math reasoning. What is math reasoning? Well, taking real world situations and understanding them. A lot of times this is our word problems where our kids have a lot of difficulty with. And so again, if they're confused by the language and the word problems, what can I do? And again, vocabulary pops up, right? Numberless word problems. If you've never used numberless word problems and you have any questions, please contact me. I love these things. They really help our students to understand, again, the process, just like CSP did, so does numberless word problems. And then, of course, content scaffolding progression. There's a whole thing on that, which is what we went over today. It's there. So if you need any of these links, please feel free. I want to stick my email in here. Or either one of these will get to me. Please use them. If there's any questions that you have regarding mathematics. Now, if you have questions about literature, I'll send you to Chastity. If you have questions about behavior, I'm going to send you to Doug. If you have questions about due process, you can call Denny Paul. So, like I said, and then we got into the part of mathematics that is a concern for all students. That's how this is broken down. So then here's mathematics for all students. And we talked about what do we need to put there? Repetitive practice, which goes right back into that explicit instruction. Cover copy comparison here. Cognitive and metacognitive strategies, which are huge, which is part of that CSP. It's part of PRT. All of those are under that metacognitive strategy. So another thing that you may want to look at is the resources that are provided here. I recommend if you're dealing with fractions, and we all deal with fractions, I know that, but go down to the part where it says articles, and there's a part down here where it says What Works Clearinghouse. They have some great articles, and if you have not used them, please use them. But What Works Clearinghouse has a article called Developing Effective Fraction Instructions for K through 8. It is extremely valuable. It's got some great resources inside of that article, and I highly recommend it. So keep that in mind. So like I said, this is the tool we use. We've developed it. We try to put as much stuff as we could for you guys in there. And so